For us, it's actually a deceptively simple list. So I really believe that still we need greater efficacy, greater genome editing efficacy, or genetic modification efficacy. And we need significantly enhanced delivery. And those two are not separate technologies, right? Because the challenge of, and one of Scribe's goals is to really be able to apply CRISPR genome editing broadly in vivo. And the challenge there is that delivery all of a sudden becomes incredibly important. And the most advanced delivery technologies that we currently have, AAV for organ systems like the CNS, the eye, the muscle, is specifically limited by how much you can dose, right? AAV is dose limited. And LNPs, likewise, they only really go to the liver. And that's just what saturates them. So if we want to unlock these other organ systems beyond the liver, beyond LNPs, we really need more and more efficient and specific genome editing systems. I think beyond that, we need to be building in new ways to either utilize the delivery technologies that currently exist, like LNPs, like AAV, and really kind of leveling up that technology, enabling it to function at a lower and lower dose, for example. As well as then we also really do need to focus on building new delivery technologies that can give us greater specificity for certain cell types, that can deliver CRISPR systems as potent and short-lived, effectors, essentially. And that has to be brought in as well.
Yeah, happy to chime in too. I think Ben's totally right. I mean, it's this various delivery technologies and building that out is crucial. And I think an interesting question to ponder is how we get there. And I think one thing that I've stressed to trainees over the years, and I think Ben and I both learned from each other a lot about this. And it's one thing that's deeply embedded in Scribe is the importance of the assay. It oftentimes doesn't get a lot of attention because it's kind of less interesting. It's sometimes a slog to build, but you've probably seen plots before about the exponential increases in DNA synthesis and sequencing capacity that's outstripping Moore's law. But you think about how you're going to put that technology to into play and take advantage of it. You still have to assay. You still have to wield that power in a way and learn something from it. And so Scribe really thinks about the assay, and I think that's clever developments there is one way to see advances ultimately in things like delivery.
If I could just parlay off of that, I think it's a really important point. And it's one that we critically see, right? When I say CRISPR systems need to be more efficacious, many folks are like, what do you mean? I see Cas9s out there editing at 100%. But that changes very rapidly, and especially with all of the new technologies that many folks are trying to bring forward, it changes very rapidly the second you get it into a therapeutic context. And you are limited. You are in an assay, or you have to measure this where you only have one molecule per cell or less, or one copy of that gene per cell. And it's something that I see kind of time and time again, is the difference between really academic science and moving more towards the reproducible biotechnology, or biotechnological assets that we need to create. And that is a real challenge that we're very focused on solving.